Hi guys, we're starting Unit 6 today. Remember back to Thursday when we did our blue circles on the back board? We labeled all the different parts of what a circle is. Today we're going to talk about the specific definitions and labeling them as pertaining to a circle using points. So if we look at our I can statement, it says, I can classify parts of circles and apply properties of tangents. So that's what we're going to be doing today. We're going to be talking about the parts of a circle, and we're going to apply them as properties of tangents. So our first vocabulary word is circle. The definition says a set of all points in a plane that's equidistant from the center. So obviously here's a nice pretty picture of a circle. Okay. Our next vocabulary word is center. It is the middle point on the circle. So this apple right here, I'm going to darken it in. And this is the center of our circle. Okay, you want to label that center of your circle. And then your other two on this line, radius is a segment whose endpoint is on the circle and at the center. So here we have our apple, and then let's make a point out here at the side of our circle. And then we can draw our line, and that is our radius. The last one on this line is called diameter. It's a chord that goes through the center of the circle. And so we've all seen the diameter before. It starts and ends on the circle, but it also goes through the center of the circle. Let's take a look at the next one. It says chord. Some people like to say chord, but it's actually chord. It's a segment whose endpoints are on the circle. So if we have two endpoints on the circle and we connect a pretty line in the middle, that is called a chord. The next one is secant. Secant kind of goes right along with chord, but secant is a line that intersects. And so if I have my same two endpoints on the circle, but then I have arrows, which says that this is a line, that is what a secant is. So if you take a look at chord and secant, they're kind of the same thing, but a chord does not have endpoints. It's a segment. And a secant does have arrows because it's a line. The last two, the first one is a tangent. It's a line that touches a circle in exactly one point. So if I put a point on my circle and then I go ahead and draw a line that has arrows, that is the tangent of the circle. And then the last one is common tangent. It's a line, ray, or segment that is tangent to two coplanar circles. So this is a line, a ray, or a segment that touches two circles at the same time. In this example right here, there's two common tangents. So now we're going to use our 8 vocabulary words, and we're going to look at these lines and segments and decide which one of the 8 vocabulary words is talking about. The first one says A to C. So as I look at A to C, that looks like a radius. Going down, the next one says the line FH. So if we see that line FH, it's touching both the circles in one spot. So we're going to call that our common tangent. Next, it's asking for the segment AD. It goes all the way across the circle through the center, and so that would be a diameter. And then last but not least, the last one we're going to take a look at is CH. So it goes from the center out to the side. And if it just goes halfway across the circle, it is a radius. Let's take a look at the next part. It says DE. It touches two circles. It's along the bottom there, so that would make it a common tangent again. The next one is CD. It starts in the center, goes down to the side, just goes halfway across that circle, so again, it's a radius. The other next one says E to G. That's on this little circle over here. It's just this little tiny half a circle, so that's also another radius. And then last but not least, it says FH. FH is this line. Actually, it's just the segment part because it doesn't have any arrows, and that's also another common tangent. All right, we got one more row, and we're talking about the first one. It says the line for, or the segment from A to B. So it starts at A and ends at B. So that is a chord. But the next one says the line AB. So it actually is the one that includes the arrows. So that one is the secant. Next, they're talking about this little GF on the little circle. That is a radius. And then last but not least, they're talking about the segment D to E. It starts and ends on one circle again, so it's a common tangent because it intersects two circles in one spot. Next, we're talking about tangent segments from a common external point are congruent. So if this side is 3x plus 2, and this tangent is 17, if they say they're congruent, then I can take and I can write the equation 3x plus 2 equals 17. I can find out what x is from there by subtracting 2 from both sides and dividing by 3, so x is 5. That's from tangent segments from a common external point. Now the next one says a line is tangent to a circle if and only if the line is perpendicular to the radius of the circle at its endpoint on the circle. So what that's saying is that these are right angles. They have to be right angles. Sometimes we may have to use the Pythagorean theorem to figure out if they are right angles. Concentric circles are two circles that share a common center. So if I have a large circle, here's the center, and then I draw another smaller one on the inside. Those are concentric circles. And tangent circles are two circles that touch each other in one point. So if I have a big circle and a little circle and they intersect right there at that point, those are tangent circles. All right, go ahead and flip your paper over to the back side. And it says, how many points of intersection do the pairs of circles have? Circle these points of intersection. So if we look at these two circles, they're not touching at all. So they have 0 points of intersection. If we look at number 2, it looks like we have a point here and a point here that they touch. So there's 2 points. Number 3, they don't touch at all. Number 4, they just touch in this one spot. And same with number 5, they just touch in that one spot. Those are called points of intersection. Now, 6 through 11 are talking about how many common tangents. So how many straight lines can I draw that I touch the circle in exactly one spot? So if I look here, I can draw a common tangent through the top of these two circles. See how it intersected here and here? And then also through the bottom of those two circles. So here and here. Okay, so they have 2 common tangents. This next one, they have no common tangents. You can't draw a line that goes through both of those circles just once. Number 8, there are actually 4 common tangents. So here are the 2 obvious ones, the top and the bottom. And then I'm going to switch color, and I'm going to draw the red ones in, because you can also go diagonally through the middle. And those are also common tangents. So there's 4 common tangents there. Number 9, there looks like there's just this one. Okay, it just touches in one spot. So there's 1 common tangent. Number 10, there are 1, 2, and then don't forget about through the middle, there are 3 common tangents. And then the last one, number 11, gets a little bit difficult. And so you can draw 1, 2, 3 different tangent lines for number 11. Okay, so make sure you have all those tangent lines drawn in. There are quiz questions on this on Friday that are exactly like this, so you already have the answers as long as you are writing this down. Let's look at 12, 13, and 14. It says, is AB tangent to the circle C? So in other words, do we have a right angle? So if I'm given 3 different numbers, I can just use the Pythagorean theorem real quick to see if these values equal each other. And as you type them in your calculator, you get something equal to something. You notice that they're not congruent. You can also look right here at angle B. That does not look like a right angle. So AB is not tangent to the circle. Number 13, if you look, is AB tangent to the circle? The right angle is in the wrong spot. The right angle is at D and it should be at B. So we know automatically that nope, it's not tangent to the circle. And then last but not least, we have numbers again, so we have to do that Pythagorean theorem. So I'm going to take and see if these guys are equal. And when I do, I think we get 7,225 and 7,225. So those two numbers are the same. And yes, it is. You could also look automatically right there at that right angle and notice that you do have perpendicular lines, so you do have a tangent. And then this last piece is just going back to what we talked about on the front. We need to name a radius. So a radius goes halfway across the circle. That's going to be BC with just a segment notation over the top. 16S for a diameter. That's going to be GH on the little circle with a segment notation over the top. The center, the point in the middle, is B. A chord on the circle is going to be AF with segment notation over the top. A secant's going to be AF with line notation over the top. A common tangent is going to be DE with a line notation over the top. Point of tangency is just going to be the letter E. And then a tangent line is going to be CD with line notation over the top. Now you're going to get your homework. Your homework looks exactly like this. You're going to play some matching with our vocabulary words. You're going to figure out if things are tangent. And then you're also at the end going to be setting two equations equal to each other and solving for x.